Dhanusri IIT Kalpaka. I'm going to speak on the topic light, reflection and refraction. First, define what is light. Light is a form of energy which helps us to see the object. It gives a sensation of vision. Light falls on the object, it will get reflected back, and those reflected rays enter through our eye, which makes us the object visible. Most of the objects in the universe is able to be seen by our eyes with the help of the irregular reflection. Reflection is of two types, regular and irregular. Most of the visibility of our eyes is caused by the irregular reflection. Now, let's see the common properties of light. Light always travels in a straight line and it does not require any material medium for its propagation. Now, let's move on to the next slide. Now, let's define the reflection of light. When a light falls on a highly polished surface like a mirror, most of the light is sent back into the same medium. This process is called the reflection of light. Here the important point is the light will be bouncing back into the same medium. Laws of reflection. There are two laws of reflection. The angle of incidence is always equal to the angle of reflection. The angle of incidence and the angle of reflection in any surface will be equal and the angle between them will also be equal. The incident ray, the reflected ray and the normal at the point of incidence all will lie on the same plane. Now let's go upon the properties of the images formed by the plane mirror. The image which is formed by the plane mirror is always erect and virtual in nature. The image is same as the size of the object. The image is at the same distance from the mirror as the object is in front of it. The image is virtual. It cannot be obtained on a screen. The image is laterally inverted. The left side will be visible as right side and right side will be visible as the left side. And the focal length of the plane mirror is always infinity. This is the important point which we have to remember. Uses of the spherical mirror. There are other two types of mirror which is carved out from a sphere. They are known as concave mirrors and convex mirror. These are used in our daily life in various appliances. First we can see about the concave mirror. Concave mirror are the mirrors in which the inner surface acts. Concave mirror are the mirrors in which the inner surface will act as the reflecting surface and the outermost surface will be polished and it won't provide any reflection to it. Now the concave mirrors are used in the torches, searchlights, headlights as makeup mirrors and most importantly it is used as a shaving mirrors and it is used by dentists. Now we can also see that this concave mirror is used by as in the shaving mirror and it is also used by the dentist in order to examine our teeth. It is also used in the solar appliances and solar furnaces as it acts as a converging mirror. The another name of concave mirror is converging mirror. Now the second type of mirror is the convex mirror. This mirror will always provide the image which is virtual, erect and diminished. This mirror is importantly used as the rear view mirrors in the vehicles and in also mall security, shop security mirrors it is used. Why it is used for the rear view mirror means the image which falls on this mirror will be virtual, erect, diminished. This convex mirror is used in the rear view mirrors because it provides a larger field of view and it always provides images which are virtual, erect, diminished irrespective of the position where the object is placed. Now let's see the sign convention rules for the spherical mirrors. The object is always placed on the left of the mirror and the light from the object falls from left to right. All the distances will be parallel to the principal axis measured from the pole. All distances measured to the right of the pole are positive and all the distances which are measured to the left of the pole are negative. The height is always measured in the perpendicular way. When the height is above the principal axis, it is considered as positive. When it is below the principal axis, it is considered as negative. Let's take up a concave mirror. In this, the direction of the light will be from left to right and the distance which is in the right hand side will be positive, and if the image is formed below the principal axis, the height of the image will be negative. And now let's see about the mirror formula. Mirror formula is 1 by f equal to 1 by v plus 1 by u. This is the mirror formula. Here v represent the image distance, u represent the object distance, and f represent the focal length of the concave mirror. Now magnification for a spherical mirror. Magnification of the spherical mirror is the ratio of the height of the image to the height of the object. It is given by h1 by h0. In this hi or h1 represent the image height or the size of the image, and h0 represents the object height or the size of the object. Magnification is equal to 1. In this magnification, if the magnification will be always equal to 1 in the case of the plane mirror. Refraction of light. When the light travels obliquely from one transparent medium to another, it bounces back into the another medium. This is known. When the light enters from one medium to another, it experiences bendage in it. Now, when the light moves from rarer to denser, when the light enters from the denser medium to rarer medium, the incident ray will go away from the normal. This is also a kind of refraction which takes place in our daily life. When the incident ray is incidenting in the obliquely towards the plane mirror, then it is known as oblique incidence, and the refraction will be 0 in this case. Refraction of light through a rectangular glass slab. This is an experiment which we can try in our home also. When a ray of light passes through a rectangular glass slab, it gets bent twice at the air glass interface and at the glass air interface. The emergent ray is always parallel to the incident ray and it is displaced through a distance. Here, when the light enters through the glass slab, it makes an angle with the normal, which is the angle of incidence. Further, if this is the extended ray of the incidence, if it enters from the rarer medium to the denser medium, it bends towards the normal. So here we have the angle of refraction, and it further moves and it emerges out of the rectangular glass slab, and this ray is termed as emergent ray, and the distance between the emergent ray and the original incident ray is the lateral displacement, which is always be perpendicular. And in this we have taken the rarer medium as air and the denser medium as glass slab. Now let's see the laws of refraction. The first law states that the incident ray, the refracted ray and the normal lies on the same plane. The ratio of the sine of angle of incidence to the sine of angle of refraction is always constant, and this is known as the Snell's law. Sin I by sin r is equal to constant. Now let's see what is refractive index. The absolute refractive index is the ratio of the speed of the light in the air to the speed of the light in vacuum. Generally, C represents the speed of light in air, which is always equal to 1 into 10 power 8 meter per second. Refractive index will be taken as speed of light in air divided by speed of light in the medium 2. The relative refractive index will be given as speed of light in the medium 1 to the speed of light in medium 2, that is given by V1 by V2. Spherical lenses. A spherical lens is a transparent material bounded by two surfaces. One or both of them will be spherical. Spherical nature are of two types. It is convex and concave. Convex lens is thicker in the middle and thinner at the edges. Rays of this will be always converging at the point of the principal axis. Concave lens is thinner at the middle and thicker at the edges. Rays will be diverging from this concave lens. Convex lens is known as the converging lens and concave lens is known as the diverging lens. Sign of conventions for the spherical lenses. The sign of convention same which we applied in the spherical mirrors will be applied here. we will take the direction of light from left to right, and the distance which is in the right will be positive, distance which is in the left will be negative, and if the height is measured above the principal axis, it will be positive, and if the height which is measured down to the principal axis will be negative. Length formula. Length formula is given as 1 by f equal to 1 by v minus 1 by u. F, v, u are represent the same which we told in the mirror formula case. Magnification produced by a spherical lens will be minus of h naught, hi by h naught. Power of a lens. Power of a lens is defined as the reciprocal of focal length, or it is the ability of the lens to converge or diverge a beam of light. The SI unit of power is diopter, and one diopter of a lens which has a focal length of 1 meter is defined as the 1 diopter. The power of a convex lens is positive, as the focal length of the convex lens will be positive, and the power of the concave lens is negative, as the focal length of the concave lens is negative. Thank you.